Hi guys, welcome to another chemical engineering tutorial brought to you by the ChemEng student. In this lesson we're going to take a look at how to plot 3D surfaces using Microsoft Excel. Now this is the first video for our December competition, whereby instead of giving away £500 every month for a year, we're going to give away £1,000 every month for an entire year. So be sure to check out the question at the end of this video. So just a quick overview as to what we're actually going to simulate. Now we're going to simulate and create 4 different elements. We're going to create a 3D surface plot using 3-dimensional coordinate systems. We will have a data summary table which will highlight the minimum, the maximum, the average and also the standard deviation. We will then create what's known as a frequency table, which will then allow us to create a data spread histogram. And what this allows us to do is get a better understanding of the distribution of our data set. Now the equation that we're going to use is z equals minus 4x squared minus 4y squared plus 2. Now we're doing this in the form of a slightly symmetrical parabola. Now this is just so that our plot looks fairly symmetrical and good to the eye, whereas in real life your 3D plots may not look as nice as the one that we are going to simulate. Now a summary of what we're going to be able to produce is as follows. So this is what you'll be able to produce by the end of this tutorial, and this is your 3D surface plot whereby we have our x-axis here, we have our y-axis going in to the page, and we have our z-axis to the left. Now I'll show you how to render this, how to manipulate the view and so forth, so that you can get the best possible chart that you need. Now our data distribution histogram, we will produce something that looks like this. And what this allows us to do is work out the most prominent and the most common values within our entire 3D coordinate set. Now this is just an additional part that's useful in terms of analysis of statistics. Now before we look at the Excel plot, I will introduce the question for the competition. So this month, instead of winning £500 every month for a year, you're going to win £1,000 every month for an entire year. So in the course of a year, you will earn £12,000. Now the question that you have to answer is, what can a 3D surface plot interpret that a 2D surface plot cannot? Now to enter, you simply have to comment your answer to this video, like and subscribe to the channel, and make sure that you are subscribed to the Facebook page, as this is where the winner will be announced on the 5th of January. So without further ado, let's head over to our Excel sheet and we will see what we're about to produce. So this is what you will be able to recreate by the end of this video. Now I will go at a slightly slower pace so as that you can follow in real time, but feel free to stop, pause the video, or even slow it down. So what we have here is we have our x coordinates in the orange top line here, we have our y coordinates here, and then our z coordinate is all these values inside this table. Now this will allow us to create this 3D surface plot, and after which we will then create our data analysis table. Now this is just a very basic and simple analysis, because that will be used in order to create our frequency table. And then from this we can then create our frequency histogram. Now again, your chart and your dashboard does not have to look like this. With the colours, the format, the rendering of the charts, you can make it look however you want. This is just one way for us to lay this out. So if we start off by opening up a new sheet, and what we'll do is we will begin with creating our data table. So I'm going to call this the x-axis, and I'm then going to give our value. So it was minus 2.5 minus 2, oops, we'll go along this way, minus 2, minus 1.5, and so forth. And we'll go along so that this is completely symmetrical. We'll go to positive 2.5. Now from here, what I'm going to do is, just to make it a bit neater, is I'm going to come here to the merge and center. And what this will do is this will create one giant cell and it will center the text in the middle. It just makes it look a bit neater. Now I'm going to do exactly the same thing here, but this time it will be for the Y coordinates. And rather than writing these values, we just highlight, and Excel will pick up the pattern and we'll go all the way down to 2.5. Now here we will label this as X-axis. Now this time we do exactly the same thing, but we highlight all the vertical cells and we put merge and center. And then we end up with something like this. Sometimes what will happen is your value will come down here. Now if that's the case, you just need to come here and this will middle align your title. So that'll just put it in the middle. Now from here, I'm just going to quickly tidy this up. I'm just going to give it some colors. And we'll give it some thicker borders just to isolate our headings. So again, this is 100% completely optional. You do not have to do this step. For me, it just helps lay things out in a bit neater fashion. And then we'll put this in a box, and then we'll call this the Z axis. Something like that. What we'll do is we'll merge that and we'll put that in the center and we'll make it bold. So this has got our initial data set up. Now here, what I'm going to do is I'm going to type in our formula. And from the PowerPoint, you will notice our formula was the minus 4x squared minus 4y squared plus 2. Now there is a multitude of different ways in which you can input this, and for me I tend to use a lot of brackets, purely on the basis that if you aren't 100% confident in your formula input and basis, then using multiple brackets ensures that you aren't telling Excel to do too many calculations at once. So what I'm going to do is open a bracket, put minus 4 times, open another bracket, and I'm going to click on the first x coordinate, and we're going to give that to the power 2. I'm going to close both brackets. I'm going to put a minus, open a bracket 4 times, open another bracket. Now this time I can't click the first coordinate for the y-axis, but I know that it's C4, so I can just type in C4 and to the power 2, close both brackets, and then I need to put plus and then 2. And from there I'll just hit enter. Now we could put this in multiple times. You could write this as many times to fill the space. However, what we can do is we can tell Excel to fix the column and the row. So in order for us to do this, what we will tell Excel is we want it to fix row 3. So in order to do that, we will put a $sign between the D and the 3. So what this says is you keep row D, but fix row F. Okay, and then we do the opposite for the Y values. We want it to fix column C, but vary the row number. So we put a $sign. Oops, we put a $sign here, and you just click enter again. And what that will allow us to do is we can drag along like so, and then we can drag down like so. And you can just check whether your system works or not. You can see these two coordinates here. We can check here, and you'll get that value and that value. So again, I'm just going to tidy this up. We'll put a border and we'll make the values bold. So this has done the first part. Now, what we could do from this point is we could make the plot just now. But what I'm going to do is I'm going to create these tables here first. All right, just so that I get the layout, and then we can go about and produce our 3D surface plot. So from here, we're just going to have our minimum, our maximum, our average, and our standard deviation. And I'll explain why we need these in just a second. So we come back here. Then what we'll do is we'll call this analysis table. And again, because we have two columns, I'm going to merge and center this cell, and I'm going to give this one a heading or a shade of green, because normally for me my green indicates that this is some form of analysis table. So I'm just going to put, I will call it min value, We'll then call it the max value. We'll then put average value. And then we'll have our standard deviation. Now, if you see this assortment here where your cell text overlaps into the other one, just come up here, double click, and it will automatically render for you. And I'm just going to give this a nice bold colour here. Now, what I'm then going to do is I'm going to work out what these values are first. Then we can proceed to the chart. So what I want Excel to do is identify the minimum value of this entire data set. So I'm just going to highlight that and close the bracket. So the smallest value that we possibly have is minus 48. And then I want to ask Excel to work out the maximum value. So equals max, open a bracket, close the bracket, we get a maximum value of 2. Now there are two ways you can find the average. You could add these together and divide by 2. Or Excel has an average function. So normally, just to stay consistent, I would use the average function and hit enter. Now we don't have to use the full standard deviation formula because Excel has it already pre-programmed. So it's STDEV, so standard deviation, open a bracket and highlight the full data set again. Close the bracket, hit enter. Now here, I don't want it too many decimal places, so I'm just going to give it to the nearest whole number. So in this case, the standard deviation is 13. Now the standard deviation tells us the spread of our data set. Now what we ideally want is the smaller the standard deviation, the more concurrent our data set becomes, i.e. the more consistent and closer these values are. So the larger the standard deviation, the wider the spread of your data set. Now I'm going to set up the frequency table. In fact, I could just put frequency table like so. And again, I'm going to merge and center. I'll give it some green and I'm going to bold the heading. Now, I'm not going to fill this out just yet because I'm going to come to our 3D surface plot. Now, in order to create this 3D surface plot, what you have to do is we have to come and highlight the Z coordinates. So that's the ones in the calculations that we did. Now, what we can then do is come to Insert, and you will see you have some of the most common charts here. But if you want to see them all, what I tend to do is click this button and come to All Charts. And that way I can get a preview of what my chart is going to look like. Now we don't want lines, bar charts, XY scatter graphs. We don't want any of that. What we want is a surface plot. Now we have 3D surface plots. We have 2D contour plots. And we can have it whereby we don't have whole colours. We just have the different mesh lines in here. But what I'm going to do is I'm going to go for a solid 3D surface. And then I'm going to click OK. And what we'll see here is a nice big surface plot like so. Now that is technically how you would create your 3D surface. But the issue is we want this to look a bit nicer. Because as it stands just now, this may not give you the full information that you are looking for. So we can clearly see that on this axis, this is our Z axis. Now we want to give us some titles. We want to give us an overall chart title. And we may want to change the appearance and like the color spectrum, as well as the rotation of this chart. So the first thing that we can do is we will change the color. So again, you can have a multitude of different variations. For me, what I tend to prefer is to have the same color throughout, just different shades. So you can have a wide range of different colors. Now, I think I went for the orange because what I used was a black background. And again, this is completely optional. You do not have to do this. You can keep it as white. You can keep it any way you possibly want. But I thought it makes it stand out a little bit better, so I went for the black. Now we already have our title, so we could change this and put 3D surface plot. Again, you can call it whatever you want. This doesn't have any specific system, so there is no meaning towards these values. And you can see why we used a kind of parabolic shape, because it makes it look quite nice. Now, I'd instinctively ensured that we would have a maximum turning point rather than a minimum. Now, what we can then do is we can come to quick layout if you want, and there's a series of different preset layouts. So you can have where some of the axis is gone. You can have other ones whereby it shows all the mesh. I think I'm going to go for this one here. Yes, because we want to show all the mesh in this case. Now, if we compare with this, we can see that the angle is slightly different. So this is the preset angle. Now, this is 100% completely optional. But what we can do is we can right click and you can format the chart area. So in doing so, what we have here is I will bring this across first so that we can see this, and we have a series of different options. We can format the floor, we can format the area, and so forth. Now, one of the things that we can do is you can even change the legend, so that's here. You can change its size, you can give it a border if you want. Now from here, what will we change? We can, whatever you select, it will pre-highlight for you. So again, you can click on the axis, it'll tell you where the data plot is. You can double click if you want, or you can just use this set here. So we can come to 3D format, and we can come to 3D rotation. So that's in the plot area options. So that is in the effects tab here. So we scroll down and we can change the angle of rotation. Now, I think for the one that I reproduced to start with, my X rotation was 30 degrees, my Y rotation was 20 degrees, and my perspective was 20 degrees as well. Again, that is completely optional. You can change this to however you want it to look. So whatever axis you think is most prominent, that's the one that you want to view. So we can look at it from an under perspective. You can look at it from a slightly bigger bird's eye view, whichever one you want. But for me, this sufficed. This was good enough for this particular system. So we'll come out of here and I'll bring it back, and what we'll do is you can add char elements. So we can give axis titles. Now we know that the depth in this case was the Y value, we know that this was the Z value, and we know that this is the X value. Now we do have a slight issue, because the series name, that's not what we want it to display. What we want it to display is the X coordinates and the Y coordinates. So what we can do here is we can come to select data. Now here, what we can do is this would be our X axis. So what I can do is come to here, and what I can do is I can highlight these values, like so. Then I can come here, and each series, so as it stands just now, that's your Y axis. So you can clearly see that we don't want it to be called series. So what you do is you click edit, and you have to do this for each one. So it does take a bit of time, and you just select the value of each cell, and you'll see that it changes. Now it does take a bit of time. There is no quicker way of doing this. You just need to be a bit patient and just make sure that you don't get them round the wrong way. So again, we'll just go to 0, series 7, so that's us now into the positive values. Series 8 will give us 1, series 9 will give us 1.5, 10 will give us 2, and series 11 will give us 2.5. So when we do that, we click OK. We can now clearly see that our y-axis is rendered properly and our x-axis is rendered properly. Now what we can then do is we can come here and we'll add some axis titles. So down here we'll call this x-axis, something like that. Now if you want to make this bigger, then what you can do is come here, make sure you have highlighted this, and we can just increase this as much as we possibly want, and we can change it and move it wherever we need to. Okay, then what we can do is we can come to chart design and we'll add another axis title. This time we'll call this the z-axis, and we'll hit enter like so. And then we'll give our last one, which was the depth, which was our y-axis, like so. Alright, now again you can change the size, you could even change the font style as well. Alright, so that is how you would create and render your 3D surface plot. So it is very straightforward. Once you see the process, you just do it in a systematic way. Now I'm going to set this just to the side just now, and then I'm going to come down to my frequency table. Now this is where we're going to be able to produce our frequency distribution chart. Now, in order to do this, we needed to use our data analysis tab, because what we want to tell Excel is we want to know what range we have to specify our data set is. So our minimum value is -48, which means we have to go ever so slightly less than the -48. So I'm going to go for -50. That means that that is ever so slightly less than our minimum possible value. So you can see here -50. Now what I'll do is I'll type in range and frequency, just so that there is no ambiguity as to what is what. So I'll do that, and then we'll have -50. Now what you then need to do is you need to decide on equal increments. Alright, so in this case the equal increments we made is 5. Now you may ask how far you have to go, and in this case the farthest we have to go is ever so slightly above the value of 2. So we can go to, in this case, 5. So once you have your pattern there, you just highlight it and Excel will pick up the pattern like so. So we'll come down to this set here. So that covers the range of our entire data set. Alright, so again, I'll just bold this. This is 100% completely optional. You do not have to do this. Now, the frequency, there is a function in Excel which will tell us the frequency. So you type in equals and then frequency, open a bracket. Now the data array is the data that you want to use. So that's going to be this entire set here. Now we then want to separate with a comma, and the bins array is the values that we want Excel to use to compare and count towards. So that's going to be a range column. Now the one key condition here is that you highlight every single value except the last value. So we click at the 0 and scroll all the way up to I think it's C25 or B25. Now close the bracket and hit enter. And what you see here is the pre-populated frequency of our data set. And this is important because this allows us to create a frequency histogram. So highlight your data, come to insert, and we'll come to all charts. And what we're going to give is a 2D bar chart, something just like this. You can produce an actual histogram, but for here, this will suffice. This is enough information here. So again, what we'll do is we'll make this ever so slightly bigger, like so. And again, you can change how this looks. I'm going to stay consistent with the dark. I'll give it a title. So this is data frequency. You can call this whatever you want. So distribution, if I could spell, like so. And then what I could also do is give it some labels. So I could call this data range, like so. Enter. And then I could give another chart here, and we'll call this the frequency. So that tells us that the value, so the data between minus 20, we have 20 values that are within the range of minus 20. Now what that means is there is a tolerable difference between here and here. The smaller your increment, the less these values will be, but you'll have a wider data spread. So that's how you create your 3D surface plot. We add in a bit of statistics. Now if you want to make yours look exactly the same as mine, normally what I do is once I have my core inputs, I can then create solid backgrounds. So what I do is I highlight a wide range of cells and I fill it in so that it is white. So what that does is that kind of takes away the lines. And there's a few different ways that you can do this, of course. This is just one way that I tend to use it. But again, there is so many different ways in which you can fill this out, like so. And that is how you would create a 3D surface plot, as well as a data analysis table, frequency table, and a distribution histogram. So that's the end of this lesson. Thanks for watching. Hopefully this was helpful in understanding the idea and concept of creating 3D surface plots in Excel. If you liked this video, please consider liking to the channel. It really helps us reach as many chemical engineering students as possible. Thank you for your time, and we hope to see you in another video.